Have you ever asked an AI a super simple question only to get a completely wrong answer back? It's one of the most frustrating things about this incredible technology. Well, today, we're going to peek inside the AI's brain to see how a brand new method is making these tools smarter and way more trustworthy.
So let's just dive right into the central mystery here. We have these ridiculously powerful large language models, right? I mean, they can write poetry, they can code complex software, and yet you ask them a basic factual question, and they can confidently tell you something that is just flat out wrong. How does that even happen?
Okay, check this out. This is a perfect example. You ask an AI, what's the capital of British Columbia? It's very, very likely to say Vancouver. Why? Because Vancouver is the most famous city. It's the one it has seen mentioned a million times in its training data. But it's wrong. The correct answer, of course, is Victoria. The AI went with the popular choice, not the factual one.
This whole issue actually has a name you've probably heard. Hallucination. It's when an LLM just, well, it makes stuff up, but serves it to you like it's a solid fact. And this isn't just some quirky little bug. No, it's a huge problem, because it completely undermines our ability to trust these tools for anything important.
So, to figure out the solution, we first have to understand the cause. And a really good way to think about it is what you could call the final thought problem. It's all about how standard AIs process information to come up with an answer. Think of it like this. When you ask a question, the AI thinks about it in a series of steps, or what we call layers. But with the standard way of doing things, it basically just listens to its final thought. The prediction from the very last layer of thinking is the only one that actually becomes the answer you see. And here is where it all goes wrong. That final layer can get way too focused on the most common patterns, just like we saw with the Vancouver example. It can totally ignore some really important subtle context that was actually picked up in the earlier layers of its thinking. So the main takeaway is, the final answer isn't always the AI's best answer.
So if the problem is only listening to the final thought, what if we just didn't? What if we listened to the entire thought process? Well, that is the brilliant idea behind a new method called SLED.
The researchers who created it basically say SLED is a way to make the AI's final answer line up better with what it already knows deep down. And you know the best part? It does all this without needing to be retrained or force-fed a bunch of extra data. It's all about using the knowledge the AI already has, just smarter.
So here's how SLED totally changes the game. The first two steps, they're the same. But here's the twist. Instead of just grabbing the opinion of that final layer, SLED goes back and gathers the predictions from every single layer. Then it combines all those little thoughts into a smart weighted average to come up with a much more refined and, you guessed it, a more accurate answer.
Okay, the theory sounds awesome, but talk is cheap. Does this actually work in practice? Let's look at a really clear example that shows how SLED can catch a mistake before it even happens.
All right, here's a pretty simple math word problem. But it's the kind of problem where you have to pay attention to all the details. We've got the number of toys, we've got the cost for each toy, and then there's that critical little piece of information, a discount if you buy enough.
A standard model often just sees the 6 and the 10, and its brain immediately jumps to the most obvious pattern, multiplication. It calculates 6 times 10 is 60, and completely forgets about the discount. But SLED, because it's listening to those earlier layers that definitely process that discount roll, it understands that another step is needed. It brilliantly corrects the path, leading to the right calculation and the right answer, 54.
Okay, that's pretty cool for a math problem. But let's be real, the big question is, does this scale up? Can this clever little trick actually improve the performance of the giant, state-of-the-art models we all use every day?
Well, the data says, absolutely yes. When they put SLED to the test on some really tough factual benchmarks, it didn't just do a little better. It consistently blew the baseline model and even the previous best method out of the water. We're talking about a huge leap forward in accuracy. In fact, when they tested it across a whole range of popular models, we're talking Gemma, GPT-OSS, Mistral, SLED boosted factual accuracy by up to a massive 16%. That is a total game changer in the fight against AI hallucinations.
This all sounds almost too good to be true, right? In the world of technology, there's almost never a free lunch. So what's the catch? What's the trade-off here? What does this incredible gain in accuracy actually cost us?
But first, let's just quickly recap the benefits, because they're seriously impressive. SLED improves accuracy without expensive retraining. It's flexible enough to work with pretty much any open-source model. You can stack it on top of other techniques, and it makes the AI smarter using only the knowledge it already has. And the price for all of this goodness? It is shockingly small. The extra processing time, or what we call latency, is only about 4% slower than the next best method. That is an incredibly small price to pay for such a massive gain in reliability and trust.
So the biggest thing to take away here is that SLED makes AI better by looking deeper into its own process. And that leaves us with a really fascinating final thought of our own. If we can fix factual accuracy just by listening to more than the final answer, what other really tough problems, things like reasoning or maybe even creativity, could we solve by applying this exact same idea?